Hello guys, welcome to a brand new crash course on React Query. In the first section, we will talk about the what and the why of React Query. And as we progress through the course, we will talk about the various features that React Query provides. So first, let us talk about what is React Query. To put it very simply, it is a library for fetching data in a React application. Now you might think, why do we need a separate library for fetching data in a React application? The first reason is, since React is a UI library, there is no specific pattern for data fetching. Traditionally, we typically use the useEffect hook for data fetching and use state hook to maintain component state like loading, error state, or the resulting data. If the fetched data is needed throughout the app, then we tend to use some state management libraries like Redux. Most of the state management libraries are good for working with client state alone. So for example, the theme for the application or whether a model is open. But unfortunately, these state management libraries like Redux are not great for working with asynchronous or server state. And when we say server state, it could be data sitting inside of a database. And libraries like Redux are not really great for working with server state because client state is fundamentally very different from server state. Let us see what the differences are. Client state is persisted in your app memory and accessing or updating it is synchronous. Whereas server state is persisted remotely and requires asynchronous APIs for fetching or updating. Server state has shared ownership, right? So there could be multiple clients, multiple devices connected to the same server. Data can be updated by somebody else without your knowledge. And because somebody else or some other device can update the server data without your knowledge, the UI data that is currently being shown may not be in sync with the remote server or the database data. And this becomes very challenging when you have to deal with caching, deduplication of multiple requests for the same data, updating stale data in the background, performance optimizations in pagination and lazy loading, etc. A lot of these problems, for example, the UI data being out of sync with the database data, caching, making sure that there aren't any deduplication of multiple requests for the same data, all of these different things, if you want to do it by yourself, you will have to write a lot of logic on the client side. Which is why it makes sense to go for a library like React Query, which solves all of these problems out of the box. You don't have to do anything. React Query has so much intelligence built in that it becomes extremely easy for a front-end developer to handle all these different use cases. So as we progress through this course, you will see how React Query makes the entire process of data fetching in React so much easier. So without wasting any more time, let us quickly jump into setting up the project. So there are a couple of very simple steps that I want us to do so that we can purely focus on React Query going forward. So the first one is we are setting up a new React project using create React app. And next up, we're going to set up an API endpoint that serves mock data for use in our application. Because if you think about it, we use React Query in our application to simplify the process of fetching data. So we are setting up our own API endpoint. And setting this up is only going to take 2 minutes because we are going to be using a very simple package. And thirdly, we are going to set up React Router and a few routes in the application. And lastly, we will fetch data the traditional way using useEffect and useState. So first off, we'll do it the traditional way. And once it is done the traditional way, we will then fetch the same data using React Query. And by comparing it, we will be able to see how easy it is to work with React Query with regards to fetching data. So without wasting any more time, let's jump into the code. So the first point is, let us set up a new React project using create React app. So if I switch to my VS Code, I have already created a create React app project right here. You can do the same by just typing in npx create React app, and then you can mention React Query demo. Press enter and you will have a project very similar to mine. Next up, I just want to clean it up a little bit. So you can see that we don't need any of these elements right here. We will also not be needing this logo right here. Let's come back to the app.css. We don't need any of this. We can delete the app.test.js. We can also delete the logo.svg. Okay. And we will also not be needing this particular class name right here. Perfect. So now we have set up our create React app application. So next up, we have to set up an API endpoint that serves mock data. So to do that, we can use a very lightweight NPM package called JSON server. So let us go ahead and install JSON server in our application. So I can say npm i JSON dash server. Okay, it is done. The second step is to come to the parent directory right here and then create a database file. So let us call it db.json. So whatever data that we put inside of here is what will be served by the JSON server. So I'm going to copy paste some data right here. Okay, so what we have right here is an array of posts. So each post is going to have an ID, a title, and a body. So the second step to setting up JSON server is done. We create a db.json file at the very top directory, and then we put some mock data inside of here that we want the JSON server to serve. So the third step is, let us go to the package.json file and let us add a fifth script right here, which is to start up the JSON server. So we can call it serve-json. And inside of here, we can say json-server-watch db.json and then space --port, and then we can tell it to point to port 4000. So what we're telling is, we are telling the JSON server to watch the database file, which is sitting at the very top right here. And then we are also telling the JSON server to listen to port 4000. So if I were to go down here and open up another terminal, and if I were to say npm run serve-json, you can now see that this endpoint has been exposed. So let me click on it. And now you can see that this API endpoint is working fine. So it says localhost port 4000/posts. So pretty straightforward. We can also have another property inside of this object. So we can also have something like to-dos inside of here. This could be another array, and we can have something like ID, which is 1, and we can have, let's say, another title, and it could be something like go to the doctor. So if I were to save the file, and I can also go to to-dos right now, and you can see that this has been updated. So this is why we use a JSON server. It helps us set up a server really quickly, but at the same time, it also allows for GET requests, it allows for POST requests, which is also something that we will be requiring in this particular crash course. Let us remove this now because we will not be needing it. Okay. So the second point, which is to set up an API endpoint, has also been done. As a next step, let us create some pages right here. So let me come inside of this source folder. Let us create a new folder called components. So the first component or the page that I want to create is the home page. So I can call it home.js. Inside of here, I can use the snippet RAFCE, which is going to create a very simple functional component for me. And I'm able to use the snippet because I'm using this particular extension. We will also not be needing this import right here because we are using React 18 right now. So we can render something like homepage. So let us now import this home component inside of the app.js file, and let's make sure that everything is working fine. So let me come down here. And to run the React app, I can say npm run start. So if I come back to the browser, you can see that we've got homepage listed right here. Now I want to create another component which is going to list out all the posts information right here. But I want to do it the traditional way. So going by the traditional way, we are going to be using useEffect as well as useState. Okay, so we are not going to be using React Query. Okay, so let us name it something like posts traditional.js. So inside of here, let me copy paste some code which fetches data in a very traditional way. Okay, so let me explain what we've done right here. So before I start explaining the code, you can see that there is an error which says cannot resolve Axios because we're using Axios to fetch data. So let us quickly go ahead and install Axios. So I can say npm i Axios. Okay, it's done. So now there is no errors. So let us do a quick code walkthrough of what a component that does traditional code fetching looks like. So right here, we can see that we have imported the use effect as well as the use state. So coming inside of the component called post traditional, we have three different states. So the first state is to hold the array of data. And the second state is to hold the is loading state. And the third state is to hold the is error state. Okay. And then right here, you can see that there is a use effect which fetches all of the posts from the API endpoint that we have just created. So this function first is going to make use of Axios and get the data from this particular endpoint. And it is going to set the data in this particular posts array. If at all there is some error in this particular fetching operation, it is going to set the error to true right here. And inside of the finally block, we're setting the is loading to false. Initially, it is set to true. And as soon as the initial resolution has occurred, we are setting it to false. And down here, we're conditionally rendering a few JSX. If at all there is a loading happening, we are saying page is loading. If at all there is an error happening, we are saying error has occurred. But if the is loading is false, as well as the is error is false, it means that the data has been successfully fetched. So we are just going ahead and looping through the posts array, and each item is going to display the title as well as the body. Very straightforward. So if I come back to the app.js, and if I were to import this post or traditional instead and go back to the browser, you can see that we've got the title and the body being displayed for every single post. The UI is really bad right now, but we will fix it in a minute. So coming back, let us also create another component, and we can name it something like posts reactquery.js. And we can use the snippet RAFCE, which is going to say posts RQ page. So next up, I want to introduce some routing inside of the app.js file. So I'm going to install this package called npm i react router DOM. And I'm going to copy paste some code in here. This code is already present in the GitHub repository. You can find the link in the description below, but you needn't have to. This is pretty relatively straightforward. Let me walk you through it. So up here, we have destructured the browser router, the routes, the route, and the link components. So what I've done here is I've wrapped the entire div using the browser router, and I've created a nav element right here. We have a UL element, and we've got three links right here. Clicking on each of these links is going to take us to this particular URL. So whenever there is a /URL pushed in the browser, it is going to redirect to this particular home component. Anytime this particular link is clicked on, this particular URL is going to be pushed, and then this post traditional component is going to be mounted. And similarly, if the third link is clicked on, this particular component, which corresponds to this URL, is going to be mounted onto the screen. And that is it. So let us now go to the browser and see how it looks like. Perfect. You can see that we've got three different links. Since we are in the root URL, the home page is currently being listed right here. So if I were to click on the traditional posts, you can see that a list of all the posts is being rendered. And similarly, clicking on the RQ posts is going to show the posts RQ page. Although it works fine, I just want to add a little bit of CSS. So I'm going to come down here to the app.css file, and I'm going to paste some code right here. So you can find the code for the CSS in the GitHub link as well. Just go into the app.css file inside of the GitHub repo, copy the entire contents of it and paste it inside of the app.css file. And now let's come back to the posts traditional component, and let me add some simple styles right here. So I'm going to add a class name here, post list. And for this div, I can add a class name of post dash item. And since this h3 is going to be the title, I can say post dash title. And similarly, let me copy this class name, put it here, and let's call this body. Hit save, and let me go to the home.js file, and let me add a simple class name of container, And I'm going to add the same class name in the posts RQ div as well. Perfect. So let us come back to the browser. Beautiful. So now we have a very pretty nav bar at the very top. We've got the home page. If I were to click on the RQ posts, you can see that it changes. Similarly, if I were to click on the traditional posts, you can see that each item is styled in a very pretty way. So with this, the setup process is complete. So firstly, we created a React project using create React app. We also set up an API endpoint using JSON server. We also set up a React router and a few routes in the application. And finally, we also fetched data the traditional way using useEffect and useState. In this section, we were able to fetch data from this particular endpoint and then list it out using the traditional method of using useEffect as well as useStates. In the next section, inside of this posts.rq, we will implement the same functionality using React Query, right? So that is what this means, posts React Query. This will give us a chance to compare how React Query is better compared to the traditional way of doing things. So we'll see that in the next section. In this section, let us implement the same functionality which we've traditionally implemented using React Query instead of this component. So the first step is let us install the package React Query. So to do that, come to the terminal and then we can say npm I at TanStack /react-query, enter. Okay, React Query has been installed. So the next step is we have to wrap the entire application with something called the query client provider. So let us go to the index.js file and we've got the app right here. Let us wrap the entire application with the query client provider. So first off, let us import a few things. So we have to import these things from the TanStack React Query library that we've just installed. And the first thing that we want to extract from it is the query client provider. And the second thing is we have to extract the query client itself. So let us now go ahead and provide it. So to do that, we can just wrap the query client provider around the app component. Okay. And the next thing is we have to provide the client inside of the query client provider. If you have used Redux in the past, then you will know what we are doing right now. So let us pass in the client. So to pass in the client, let's come up here and we can say query client camel case, and then we just have to create a new instance of the query client right here. So this query client is what we need to send inside of here. So because we've provided this query client to the rest of the application, now we will be able to access all the methods and the hooks that React Query provides. Now let's go back to the posts RQ component where we will be fetching the data from the API endpoint. Because this is the first time that we're learning React Query, let us take things very slow, one thing at a time. So because inside of here, we'll be fetching data from the API endpoint, there is one go-to React Query hook that you have to remember, and that is the useQuery hook. So let us come up here and let's import the useQuery hook. So inside of this component, let us call the useQuery hook, and the first argument is always going to be an object, and this object at a minimum requires two properties. And the first property is the query key, and this will always be an array, and let us mention posts. So let's talk about this. Why do we need a query key right here? So in React Query, every query requires a unique query key. Okay, so I'll give you a few examples. So in the posts traditional component, we were fetching data from the /posts endpoint, right? We were fetching it from /posts endpoint. So because this is going to be the endpoint where we'll be fetching the data in this particular component, we've gone ahead and put posts inside of the array, right? So the unique query key was posts. But let's say in another scenario, we were fetching data from posts/1. And in this case, it might be something like post/1, right? If it was 2, then we might have to put 2 here, right? So we might also have to make it dynamic, like saying that post.id. So this array can take multiple items as well. So pretty much any endpoint that you can think of, every single query should have its own unique query key. Okay, I'll give you another example. So if it was posts/ let's say 1, slash comments, then the unique key could be something like posts, and then the post ID to make it dynamic, and then we can put comments inside of here. So this could be the unique query key for this particular query. Okay, so in this case, since we're only dealing with slash posts, this is relatively very simple. So which is why we have left it as an array of just one item which has posts inside of it. We will talk much more in depth about the significance of this particular query key later on. But for now, just know that every single query should have its own unique query key. All right, let us remove it now. So we said that this particular object will take two properties at a minimum. So the first property is query key, and the second property is going to be the query function. All right, so this function is going to be a callback that always returns a promise. Okay, so just remember that this is a function that always returns a promise. So inside of this query function, we can go ahead and fetch data similar to what we've done right here. So we can just copy this entire thing and paste it inside of here. So the Axios has not been imported. So let us import Axios. Perfect. And don't forget to add the return here because we have to return this promise to the query function. So far we have called the useQuery hook. We passed in an object and we have specified a unique query key for this particular query right here. And we've also mentioned the query function, and this returns a promise. Perfect. So right now, this particular useQuery hook is also going to return a result object. So this result is going to be an object which has all the information that you can possibly think of about this particular query. But since we're only getting started, let us destructure only the properties that we need. So what are the properties that we need? Let's go back to the post traditional component. So here we needed the data, and we also needed the is loading or not. We needed to know if the API call was in progress or not. And we also needed to know if it has been failed or not. So these are the three pieces of data that we wanted. And the good news is we have all these three pieces of data inside of this result object. So let us go ahead and destructure it. So the first thing is we have the data, right? So whatever has been the result of this particular endpoint fetching, it is going to be in this data property. And the second one is we also get access to the is loading property. We also get access to the is error property. And finally, we also have access to the error string right here. So this is going to be a Boolean. This is going to tell you if there has been an error or not. And this property, on the other hand, is going to hold the exact error message. Okay, so let us now return the JSX. So first off, we can do the is loading. So for that, we can go to the post traditional, and then we can copy paste the same code that we've written. And for this, we can use the error.message because we are getting the error string right here. And finally, regarding the data, let us log it to the console and make sure that we're actually getting the data. So save, let's go back to the browser. Let's open up console and go to RQ posts. Perfect. Inside of here, you can see that in the data, we are getting the entire list of posts, right? So this entire array is sitting inside of the data property. So let me go to the post traditional here. Let me copy this entire thing. Come back here, replace it, and then I'm just going to say data and data.map. And now if I come back to the browser, you can see that we have the same list being displayed for RQ posts as well. If we go to the traditional posts, you can see that it is no different from what is being listed in RQ posts. So let us now come back to the component and see if it has been simplified a little bit. So right here, you can see that the entire process of fetching data and then getting all the relevant state properties only took like a couple of lines. So maximum it took like 5 lines, right? But in the traditional way of doing things, you can see that we had to define a use effect, and then inside of the fetch posts, we had to have 3 different use states and then set it accordingly. So the entire process in the traditional way would have took us close to 15-16 lines. Whereas in the React query way, it would have hardly took us only 6 lines. There is absolutely no need for multiple use states. There is absolutely no need for use effect. Everything is abstracted away inside of this one useQuery hook. So even though the requirements are very small, which is to just fetch the data and then list it out, you can see that React Query outshines the traditional way of doing things. But it doesn't end with that. Even though it seems like this is all that this is good for, React Query is much more powerful than that. We can pass in different options, arguments inside of the useQuery hook and satisfy any client-side data fetching, caching, revalidation needs that we might possibly have. So I hope that you're starting to see the power of React Query and how it can simplify things for even the simplest of things. But the usefulness of React Query becomes even more profound when things get even more complicated. All of which we'll be seeing in the upcoming sections. So I'll see you in the next section. Hello guys, in this section we will look at something called React DevTools. You should know that React comes with dedicated DevTools. And this is very important because when you're especially learning React Query, you should also know how to work with DevTools because they basically help you visualize all of the inner workings of React Query. So just know that learning React Query as well as learning how to use React Query DevTools go hand in hand. So let us quickly go ahead and install DevTools in our application. So to do it, just come down to the terminal and then you can say npm I, again TanStack /react-query-devtools. Okay, it looks like it is done. So what I'm going to do is I'm going to come down to index.js file and I'm going to import something from our newly installed package. So the package that we had just installed is the DevTools, and we want to extract the React Query DevTools right here. And this is something that we want to provide within the provider at the very bottom. And this component takes in a couple of props. I don't want the DevTools to be open at the very start. So I want it to be initially closed. So I can pass in a prop saying that initial is open and I can set it to false. Now let's save the file, come back to the browser, and you can see that there is a small icon at the very bottom right. And when I click on it, the DevTools panel opens up. And currently you do not see anything because currently we are in the traditional posts. The traditional posts page does not employ anything related to React Query. But if I were to click on the React Query posts, you can now see that we have the query key called posts because the useQuery is getting executed for this particular page. Some of the other things that you can see here are filters. Basically, if you have a lot of queries, we can filter it and we can sort it by status, sort it by query hash, and sort by last updated. But we will not be needing any of these in this course. At the top right, we also have these badges saying that fresh, fetching, paused, stale, and inactive. We don't want to worry about it right now. We will talk more about this in this course. So right now, what we can do is let's click on this particular query key. And this opens up another panel on the right side with more details about this one particular query. And up here, you can see that the status of the query is stale. We also have only one observer because there is only one page that uses this particular query. If there were multiple pages that were using the same query, then you will see that reflected right here. We can also see the last updated time. And down here under the actions category, we can see that there are several cards which lets us perform different actions related to the query. Although we have these things here, these actions are typically programmatically done in the code. So we do not want to worry about these things right now. So coming down here under the data explorer, everything that you see right here is basically just the response of an HTTP request. So we can see the status, we can see the status text, we can see several headers of this particular network request. We have the config and we have the request. And finally, we can also see the data as well. So we have an array of 3 objects, and that is what we see right here. So looking at the data right here is much more easier than going to the networks tab and then clicking on the response tab. Okay, so scrolling down, let's see what is next. So we have the query explorer. This contains a lot of information about the configuration and the current state of the current query. So we don't want to talk more about this because it might get a bit too much for you. We will talk more about this in the later sections. And that is it. As I said already, guys, having React Query DevTools installed is very important because it gives you an insight about how React Query works internally. And setting this up is something that we might have to do because it helps us learn React Query much more faster. So if you haven't installed it and configured it, just go ahead and do it, and I'll see you in the next section. In this section, we are going to be learning a very important feature of React Query called the query cache. And this is a feature the library provides out of the box. And it's very important to understanding why useQuery works the way it does. Let me show you something that you might find interesting. I'm going to empty the cache and hard reload in the browser. Right now, the DevTools does not show any query at the moment. I want you to observe what happens when we navigate to the traditional posts screen. We want a slower network speed for this example, so I will throttle it to fast 3G. Make sure the JSON server is still running and navigate to the traditional posts. We see the loading text and the list of posts. Go back home and click on traditional posts again, and again we see the loading text and the posts. Every time we do this, we always see the loading text, right? Let us now compare this with the RQ post list. If we navigate, we see the loading text and the list of posts. However, if we go back home and then come back, we do not see the loading text. And this is because of the query cache that React Query provides. By default, every query result is cached for 5 minutes, and React Query relies on that cache for subsequent requests. Let me explain in a bit more detail, as it is very important to understand how useQuery works with respect to caching. The first time useQuery is fired for posts key, is loading is set to true, and a network request is sent to fetch the data. As soon as the request is completed, it is cached using the query key and the query function as the unique identifiers. Now, when we navigate to the home page and revisit the RQ posts page, React Query will check if the data for this query already exists in the cache. Since it does, the cached data is immediately returned without isLoading set to true. And this is the reason we don't see the loading text for subsequent requests. However, React Query knows that the server data might have updated and the cache might not have the latest data. So a background refetch is triggered for the same query, and if the fetch is successful, the new data is updated in the UI. Since our data is same as the cached data, we don't see any changes in the UI. I hope this part of useQuery and query cache is clear to you. Now you might be wondering, if isLoading is not changed, does useQuery hook provide another Boolean flag to indicate the background refetching of the query? The answer is yes, and the flag is called isFetching. Let's log isLoading and isFetching to the console, which will help us better track the network activity. Head on to the browser, empty cache and hard reload, navigate to the RQ posts, and in the console, you can see that initially, both isLoading as well as isFetching is true. When the data fetching is complete, both are set to false. Let us look at another example where the data does change so that we understand it properly. Let me now navigate to the home page, and now let's come back to the VS Code. In the database.json, update the first title name to, let's say, Sundar Pichai interview 1. If we go back to the browser, I want you to first observe the list of posts. We will see the cached list from before for a split second, and then the list will update when the background refetching has completed. So interview and then interview 1. You can also see in the console, isLoading remains false, but isFetching changes from true to false. So in this way, React Query leads to much better user experience, as there is a list being displayed already and the list updates in the background as well. So this way, the user does not have to see a loading indicator every single time. I hope you've understood the importance of caching in React Query and how it helps with avoiding unnecessary loading states. So I'll see you in the next section. In the previous section, we saw the role caching plays in React Query. We saw that because the API responses are cached, the second time the same page is visited, the data is first fetched from the cache and shown instantaneously, but at the same time, a background request is made and the data is updated in the UI. Because of this caching process, the user does not have to see the loading message every single time. So the user experience was slightly improved. But I also want you to notice that the background request is still being made every single time. Because React Query assumes that the API data is always going to keep changing. So every time I go to another page, let's say the home page, and I come back, a background network request is still going to happen. You can see in the DevTools, the data is always kept in stale mode, or in other words, outdated mode. And this is because React Query always assumes that the data is outdated, even after the data has been fetched just a second ago. But what if I am a software developer who knows the product, knows the application, and I know that the database data is not going to change very often? In that case, it does not make sense to make a network request every single time we come back to the RQ posts page. Fortunately, React Query addresses this very issue and lets us configure how long a data should remain fresh. So let's come back to the VS Code. So we can actually add another property to the useQuery object called the stale time. Here, we can mention the time, basically how long we can keep the data fresh and not make new network requests. By default, the value is 0, and that makes sense because it is generally safer to assume that the server data changes often. But since I know my product, I know I can safely keep it as, let's say, 30 seconds or 30,000 milliseconds. Now, when I go back to the browser, do an empty cache and hard reload. Now, for the first time when I go to the RQ posts page, as expected, an API call is made and the data is put in the cache. Now, in the DevTools, if you notice, the query is not kept in the stale mode anymore. It is now kept fresh and it will stay fresh for the next 30 seconds. So React Query will not make the same network query again for the next 30 seconds and will always pull from the cache. Let me show it to you. Let's go back to the home page and navigate to the RQ posts page again, and you see no new network requests are made. But after 30 seconds, you will see that the data has been moved to stale now. Now, when I go back to the main page and navigate to the RQ posts page, you see the network request made. It does it once, puts it in the cache, so that for the next 30 seconds, it will not have to make another network request again. So I hope this section helped you understand how you can reduce the number of network requests by configuring the stale time in conjunction with query cache. I will see you in the next section. In this section, we will look at another exciting feature that React Query provides called polling. Polling is something that can be beneficial if you're working with applications that require network calls to be made at regular intervals of time. For example, we can think about trading applications. Let us talk about Zerodha or Grow, for example. So basically these trading applications, the data in the UI is required to be updated every single second. So in another application, it could be every 2 seconds or every 5 seconds or every 10 seconds. And React Query makes it extremely easy to poll data at regular intervals of time. Let us come back to our application in React Query posts. Let us say our posts data needs to be called at every single second. So in that case, all you have to do is come back to the useQuery object right here. And then we can introduce another property here called refetch interval. By default, the value of the refetch interval is set to false. So if it is false, it is not going to pull data at any regular intervals. But this also takes in time in milliseconds. Since our requirement is to poll this data regularly at 1 second intervals, let us mention 1000 milliseconds right here. Let's save the file, come back to the browser, and let's clear this out. So right now you can see that the posts API call is being triggered for every single second. And that is how simple polling data is at regular intervals using React Query. Another thing that I want you to note is that if I were to switch to another tab, the polling stops. Okay, so this polling only continues as long as the current tab is in focus. If there is some very important requirement in your application such that even if the user were to go to another tab, you still want to keep on polling data, in that case, you might also have to introduce another property here called refetch interval in the background. So all you have to do is set it to true and save the data, and that is it. So even if you're in some other tab, our application will still keep polling data. So I hope that you're starting to see the power of useQuery and how much it abstracts away. If we are required to build this feature out by ourselves, it could be a lot of headache and a lot of boilerplate, which useQuery provides right out of the box. So I hope you learned how to poll data using React Query. And if you're liking the course, please do leave a like and subscribe to the channel, and I'll see you in the next section. In this section, let us look at how we can make useQuery fetch data by clicking on a button. So far, what we've seen is anytime this particular component, the RQPosts component gets mounted, the posts data is fetched, right? So anytime we go to another component and come back to the RQPosts component, you can see that the API call is made. And also, anytime we go to a different tab, let's say, right? So currently we're at Google. If we were to come back to the tab, you can see that another API call is made, right? So essentially why this is happening is this particular page is going out of focus and then coming inside of focus. So these are two reasons why useQuery might fetch data. But right now we are interested in fetching data manually when a user event happens. It could be something as simple as clicking on a button. So let us see how to do that. So the first step that we might have to do is tell useQuery to not fetch this data on component mount. Okay, so to do that, we can just come down here, add another property here saying that enabled : false. So what this property does is tell useQuery to disable the automatic refetching anytime the query gets mounted. Okay, so let us see if it has actually worked in the browser. So let me come to the home page. Let's refresh the cache. And if I were to now go to the RQPosts, you can see that there is no API call getting made. There is no posts call getting made, and we don't see the list here as well, right? And that is because we've disabled the query fetching on component mount. Okay, so now we're interested in fetching the same data on a user interaction like a click of a button. So let us go ahead and add a button right here. So we can say something like fetch posts. And inside of here, we might have to add an event handler. And right now, you might be wondering if useQuery provides some method that we can actually put inside of here that is going to manually trigger the query. And the good news is yes. So we can go ahead and extract the refetch method right here. So let us go ahead and put this refetch method inside of here. So right now, if I come back to the home page and RQPosts, you can see that we are not actually fetching any posts right here. And if I were to click on this button, you can now see that the posts have been triggered, and it is as simple as that. We just extract this refetch and provide it inside of event handler. And we also make sure that the enabled flag is set to false on component mount. In the next section, we will look at how to query by ID using React Query. Over the last few sections, we have seen different configurations about fetching data using the React Query hook. What is also common is fetching data by ID. So for example, we have a list of posts right here. A user might want to click on one particular post and get taken to a post detail page to see more information about this one particular post. So to do that, there are a couple of things that we have to do. The first one is we have to create a post details page. Okay, so let us call it RQ post details page. Also take note that this is a singular post. Okay, so this is step 1. Step 2 could be configuring the route for the newly created page. So what do we mean by this? So this particular page could have a different URL. The URL could be something like, and let me put this inside of a bracket. So the URL for this particular post details page could be something like rq-posts. Okay, similar to what we have right here. and slash, and right here we can have the post ID, right? This could be 1, 2, 3, 500, 1000, whatever, right? And thirdly, we just need to wrap this particular element with an anchor tag, which when clicked on will take the application to this particular URL. Okay, so the third step would be something like wrapping each item with the anchor tag. All right, that is it. So let us now quickly create the RQ post details page. So to do that, I'm just going to come inside of the components folder, and I can say something like post details rq.js. And inside of here, I'm going to use the same snippet, and we can call this post details RQ page. We don't really want this import. All right, so the first step is done. The second step is we have to configure the route for the newly created page. So to do that, I'm going to come down to the app.js file. So what we're going to do right now does require a little bit of knowledge about the React Router DOM package right here. But if you do not know it, don't worry, I'll explain it to you. So come down here. So we already have 3 routes right here, right? So when we go to the home page, this is the root path. And when we go to the traditional posts page, we have the /posts. And when we go to the RQ posts page, we have the RQ-posts, right? And that is what we have here as well as here. Whenever this particular URL is visited, this component gets mounted onto the DOM. So in addition to these 3 routes, we also want to add another route right here. So we can say route exact path, and inside of here, we decided that we will have this to be the path param. So RQ-posts /RQ-posts / and to specify the post ID, we can put a colon right here and then say post ID. That's it. And inside of this element, we are supposed to put in the post details page that we have just created. And this has been imported here as well. All right. So now if I were to go to, let's say /1, you can see that this text which we were returning from the details page is getting rendered. So it doesn't matter if I go to 1, 2, 5,000, whatever, the same thing is going to get rendered. All right, let's come back. So step 2 is done. Let's look at the step 3. We have to wrap each item in this list with the anchor tag so that when it is clicked on, it goes to the respective post ID. For example, if the third item were to be clicked on, then the URL should point to rq-posts /3. So let us see how to do that. So come back to the posts RQ page. So this is where we are rendering the entire item. I'm now going to wrap this entire item with the link component that React Router DOM provides. So let me first go ahead and import it at the very top. So I'm going to say import link from React Router DOM. You can see that it auto completes it as well. So now I'm going to use this and wrap this entire item. So coming down here, I can say link, and then I'm going to move this entire div inside of here. And finally, we also have to specify where the application should be taken to when this particular item is clicked on. So I'm going to use a string literal right here. And first off, I'm going to say posts. So I'm just going to use the same thing, right? So we have to say /RQ-posts. And right here, I can use the dynamic symbol right here. And then I can say post.id. Because remember, each object is going to have the ID property inside of that. All right. So now let us actually give this a whirl. So if I were to click on the second item, you can see that it goes to the second post ID page. The third step is done. So what is the next step? So whenever a particular post item is clicked on, this particular post details page will typically have access to the post ID. So using this post ID, we have to make a query with this particular ID, fetch all of the details for this one particular post, and then list it inside of this component. So this is the topic of this section, querying by ID using React Query. So let us actually see how to do that. So let's come down here, and we know that useQuery is always going to give you a response. And let us now actually go ahead and import useQuery here as well. And inside of here, you know that this requires a minimum of 2 properties. The first thing is the query key. So the first property of the query key could be posts, And the second one could be, let's say, 1 or 2 or 3. So this value needs to be dynamic. This value needs to be calculated based on this particular post ID in the URL. So the good news is React Router DOM gives you access to this particular post ID, whatever is currently being viewed inside of this component. So to access that, you just need to import this useParams hook right here. And let's invoke this. And this is going to return us an object. And inside of this object, we actually get access to this particular post ID. So let me copy this post ID, put it inside of here. So let me log it in the console just to make sure that we are actually indeed getting it. We don't really need this, so let's comment it out. Now let's go to the browser. And if I were to click on, let's say, the third one, you can see that we have 3 logged right here. If I were to go to the first one, you can see that 1 is being logged right here. So we do get access to the post ID right here. So let me remove this, uncomment this out, and we can just replace this 3 with the post ID. That's it. And similar to what we did with the posts RQ page, we do need all these different data to properly list out this particular page. So let me destructure and extract all these different data. We might also want these 2 blocks of code. So let me copy it, put it down here. And next up, let us work on the final data UI. So I'm just going to destructure a few things like the title and the body from the data. All right, so let us quickly build this out. So I'm just going to wrap this with a div, and I'm going to add a very simple class name here saying that post details dash container. And inside of here, we want 2 divs. So the first div is something that holds the title, and the second div is going to hold the body. We can add class names for both of these elements. So I'm just going to copy this particular class name, put it here, and then change the container to title. And similarly, I'm going to change this particular keyword to body. And do not worry about the styles. All these styles have been provided at the very start in the starter project. So as long as you have this particular file copy pasted in your application, as long as you match these particular class names, everything should work fine. So let me save this file, go to the page. Right now you can see that, oh, it says missing query function because we've not actually done the fetching yet. So let's add the query function right here. Instead of actually putting the function right here, like how we did it the last time, I'm going to define it outside in a separate file. But for now, I'm just going to define it at the very top. So I can say something like fetch post details, and I can create an arrow function. And this is where we do the Axios fetch, similar to what we did previously. And fortunately, fetching just one particular item from our list right here is extremely easy with JSON server. I'll show you what I mean. So the JSON server is currently running on port 4000. So let us actually go to this URL and you can see the list of posts. JSON server also makes it very easy to query just one item by ID. So if I were to say posts/2, you can see that only the second item is displayed. If I were to say that I need the post with the ID of 3, it is going to give you the third object. So JSON server out of the box matches this particular thing with this ID value and queries that one particular item from the list. So let us make use of this in our fetching function. So let's come down here. Let us also import Axios as well. And we can say get, and let's post this particular URL. And we need to make this dynamic. So we can go ahead and change it into string literal, make this dynamic, and we can actually get the post ID from here. Perfect. Let's create a simple arrow function, say fetch post details, and then pass in this particular post ID inside of there. And that is it. Let's save the file, go back to the browser, and you can see that we only see the details of the first post right here. So if I were to go to the second post, you can see that we only see the information about the second post. And also notice that every single query is considered as a separate query because we're also passing in the post ID inside of here. Right now, the first post and the second post queries are cached. So if I were to now go to the third post, it is not actually going to pull from this particular cache because React query knows that this is a completely different query. Post, 1 is a completely different query. So differentiating each query with the post ID key here becomes very important. If we do not provide a unique query key for each ID, React query cannot differentiate between each query. So if I were to click on this first item, it is going to be put in cache. And if I come back and if I click on the second item, for a brief second, it is still going to be showing this first item because it thinks that it is the same query. So it is going to pull from the cache. So showing incorrect data is not a good user experience. So everything works as expected. In the next section, let us look at a very common scenario in building applications called pagination. In this section, let us look at a very common scenario that you will see in a lot of applications called pagination. For example, let's say in an e-commerce application like Amazon, which has like thousands and thousands of products, it does not display all of the 1,000 products in the single page. Instead, it gives you this option to go to the next page and go to the previous page. So this is what is called pagination. And let us see how React Query makes it very easy to do that. And towards the end of the section, there is also a bonus tip, which if implemented, will make the user experience even better. So let us see how to do that. I've already added a little bit of code. Let me walk you through that. So the first thing that I have done is I've added more data inside of the db.json file. Since demonstrating pagination requires a lot more than just 3 posts, I have created an array of several items, which are basically just an array of fruits. We have close to 20 items of fruits right here, with each object having the ID of the fruit and the name of the fruit. So this list of fruits data is available in the GitHub repository, the link to which I've attached in the description below. So the next step is to create a component which is going to fetch all of these fruits and list it out. So I have already created a component called Paginated Queries. I have already coded everything out because I don't want to waste time. But what we've done here is no different to what we've done in the previous sections. So let me quickly walk you through it. So we have a component called Paginated Queries. And right here, we are invoking the useQuery hook with the query key as fruits, because we are now fetching a list of fruits. And then we also have passed in a fetch fruits function, which is now returning this particular promise. We've also extracted the data, is loading, is error, and the error message as well. And then we have these conditional checks in place. And finally, we're extracting the data out of which we're mapping through the list, and then we're listing out the item name alone. And that is it. The component is now ready. And the last and final step is to add a route to this particular paginated queries page in the app.js file. So I'm going to come down here, and you can see that I have already added a route at the very bottom with this /paginated-fruits to be the path parameter. And whenever we visit this particular path parameter, our component is going to get mounted. So let us actually quickly test it out. So I'm going to copy this particular keyword, come down here, replace it, and then press enter. And perfect. We have a list of fruits right here. Also, there is a warning here saying that each child in the list should have a unique key prop. So let me just go down here, and then let's add a key property right here, and then pass in the ID. Perfect. So let us now go ahead and see how to paginate this list. So first off, we can set a limit on how many items should be shown in a particular page. Since we have about 20 items right here, let us set the limit to 4. So each page is going to just display 4 items. And additionally, we can have 2 buttons right here called previous page and next page for navigation. The good news is JSON server supports pagination out of the box. Let me show you how. If I go to localhost 4000/fruits, you can now see a list of the entire 20 different fruits right here. But to paginate it, you can add a question mark for query param and add an underscore and limit and set it to 4. You will see that it only shows 4 items. And in addition to that, you can also set up an underscore page query as well. So right now, since we haven't mentioned it, it is by default going to be 1. And if I now enter the page 2, it starts from 5 and ends at 8. And the same thing, if I were to do it at, let's say 3, it shows 9 to 12. And if I do it at 5, it says 17 to 20. If I were to go above that, it is not going to show me anything. Okay, just one thing to note. If you're following along with this tutorial and this does not work for you, it probably means that the latest release of JSON server is not stable. So kindly go ahead and uninstall JSON server and install it to this particular version so that we are in sync just in case. We would need useState to keep track of which page that we're currently visiting. Okay, so to do that, let us quickly first go ahead and import useState from React. And now we can go ahead and have a page state right here. Initially, it could just be 1. Let us also not forget to move this outside because it is just good practice. So let's change the URL right here. So let us copy this particular URL, come back here, paste it over here. This limit right here could be set as constant, but this page is dynamic. So this is something that varies. So let us get the page ID right here. We can convert this into a string literal and let's change this into a dynamic variable. Now we also have to pass this page ID inside of the fetch fruits function. So let's convert this into an arrow function. And now we can pass in this page ID. So right now, if I were to save this file and refresh this page, we can see only the first 4 items right here because the initial page number is going to be 1. So now we want an option to go forward to the next page or go back to the previous page. So let us add 2 buttons right here. So we can have one button which is for the previous page and another button for the next page. Let us also add an on-click handler, and inside of here we can use the setPage method. We can get the previous page and we can add it by 1. We can also add a disable property here saying that if the page is equal to 0, then it should be disabled, else it does not have to be disabled. Let's do the same thing for the second button here as well. Actually, let's go ahead and copy the entire thing, put it over here, and we just need to decrement it by 1. And also, if the page were to be 4, because we only have 4 pages, it needs to be disabled, right? In a real world production application, we do not really know how many pages a list is going to contain, but we can make some estimate based on the length of the list and some extra data that we can get from the API response. But in our case, it is very clear that we only have 4 pages. Okay, let me just quickly confirm it is 4 pages or 5 pages. Okay, so since we have 20 items, we can actually have it as 5 pages because we only show 4 items at a certain point. So 4 into 5 is 20. So yeah, we have 5 pages, perfect. So let us now quickly give this a whirl. Let me refresh the page. And if I click on the next page, okay, so it is not actually going to the next page. Okay, so it looks like we've done the operations wrong. So if it is the previous page, then we are actually supposed to subtract it. And if it is the next page, we are supposed to add it. My bad. Let us now go ahead and refresh the page again. And now if I click on the next page, you can see that the second page is queried. And then we can see the second page data right here. And the same thing for the third page and the fourth page and the fifth page. And then finally, since we've reached the last page, this is getting disabled. And if I were to come back to the previous page, and you can see that the previous page is also disabled. And that is how simple it is to do pagination using React Query. There is one more improvement that we can do on this existing thing to make the user experience a little bit better. So to demonstrate it, I will have to throttle it to, let's say, slow 3G. Let me refresh this page. And right now you can see that the loading text is shown. And then we finally have the list of items. If I click on the next page now, again the loading text is shown. And then we are showing the list of items. And the same thing happens for every single page. Since we only have 4 items listed, the layout shift is not really that visible. But there are websites where there might be 20 different things listed, and the layout shift of everything completely disappearing, a loading text showing, and then the new data getting populated might be undesirable. So in that case, a desirable option could be actually retaining the previous data, waiting for the next data to be loaded, and then replacing the previous data with the next data without ever showing the loading text. So achieving that functionality using React Query is very simple. Inside of the useQuery object, add another property right here called placeholder data. And as a value to this property, we can add the keep previous data and it will automatically import it as well. And just by adding this extra property, it will prevent the loading text from showing on the screen by retaining what was listed before. And as soon as the network call is done, the new data is just replaced without any jarring layout shift. So to demonstrate it, let me go ahead and empty the cache and hard reload. We can see the initial loading text. I now want you to pay attention to what happens when I click on the next page. You will notice that we do not see the loading text anymore. This data will be retained until the new data is actually fetched, and as soon as the data is fetched, it will then replace the existing data with the new data. So if I click on the next page, you saw that the data was fetched, but the loading text was not shown. So I can do the same thing for the next page as well. There is no loading text shown, the data is retained, and as soon as the data is fetched, it is then replaced. And that is it for pagination using React Query. In the next section, we will talk about infinite queries. In this section, we will look at how we can do this infinite scroll using React Query. So in this particular demo, you can see that as and when we click on this particular load more button, more and more data is getting appended to the previous list. So this is what we will first achieve. So once we learn how to do this, with a few additional tweaks, we can do it very similar to how, let's say, Instagram does it, where you just scroll to the bottom of the screen and it automatically appends data to the existing list. So we will see both of those use cases in this section. So let us get started. So to save us some time, I've created a very simple component called infinite queries. And all that it does is fetch data from the fruits API and then list it out. As simple as that. So as you can see right here, we are using the useQuery hook. We are only passing in the fruits item instead of the query key because we're fetching the entire list right here. And as usual, we are rendering the page is loading and the error message based on these booleans. And finally, we are listing it out. So knowing how to fetch an entire list from an API is something that we're super familiar with at this point. And just like how we did it the last time, we have added a route for this particular infinite queries component right here. And that is exactly what we have here as well. So if I go back to the browser, you can see that we have a list of all the fruits right here. And the CSS is because I've just added a very simple class name here called fruit-item. But right now, we are not interested in fetching every single item in a single fetch. Let's say, for example, we only want 4 items to be displayed in a single page. And then there could be a button below it. And there could be a button, let's say called load more. And when the user clicks on that button, another 4 items gets fetched and gets appended to the previous 4 items. And the same thing keeps on happening. So to achieve the infinite scroll functionality, there are a couple of things that we might have to change in this component. Step 1, instead of the useQuery hook, we have to use another hook called useInfiniteQuery. So let us remove this from the import. So this is step 1. And step 2 is always remember that anytime we're using useInfiniteQuery, the query function right here is always going to receive an object, and inside of the object, we get the page param property. This value just means the page number. This denotes if we need to fetch the first page or the second page or the third. So if we come back to the paginated queries, let's copy this entire string right here, paste it here, because we will have to use the same string. In this case, we get a default object inside of which we have the page param, and that is what we have to use right here. We can still leave the limit here to be 4. Step 2 is done. And step 3 is, whenever this particular component gets mounted onto the DOM, we need to tell React Query that the first page that needs to be fetched should start from 1. So to mention that, this takes in another property called initial page param, and we can set it to 1. Step 3 is done. Let us move on to the final step. The last step is to add another method right here called getNextPageParam. And this is a function which takes in 2 arguments right here. The first argument is going to be the last page, and then the second argument is going to be all pages. I will explain to you what each of these parameters mean. But on a very high level, let us look at what this method actually does. So the getNextPageParam method only has one function. It is to calculate the next page number. That is it. If the next page number does not exist, if it has reached the very last page, then it should return undefined as the next page. I hope that makes sense. It has two parameters. So as we saw right here, it has two parameters, and the first one is the last page. It contains the entire API response of the last most recent data fetch. So you can imagine the data to be an object which has the data property, the status text, headers, configuration, everything. Now, the second parameter is all pages. This is an array of objects. Each object is the entire API response of all the past data fetches. So based on all this information that we have to calculate the next page number and return it to useQuery. If the page number does not exist, then it is undefined. Based on the API intelligence on what the next page is. So what this section of the line means is, if the API were to support pagination, along with the response, it also gives you data about the next page. But in our case, the JSON server does not give us that information. So we have to do manual calculation. The next page needs to be calculated and returned from the getNextPageParam method. We know that we have a total of 20 items, and we also know that at any certain page, we only show 4 items, right? So in total, we have 5 pages. And we also know that this all pages contains all the pages that have been fetched so far. So we can do a very simple calculation here, saying that if the length of all the pages is less than 5, then we can just return all pages dot length plus 1. But if we already have all the 5 pages fetched right here and the length is already 5, in that case, we can just return undefined. All right, so let's remove this. And since we're not using this last page, we can just put an underscore right here. Perfect. So step 4 in setting up useInfiniteQuery is also done. So let us actually save this file and give this a whirl. Okay, you can see that we are getting some errors saying that it cannot read the map. So it is saying that the data cannot be read. And this is because the data that useInfiniteQuery returns is going to be a little different from what the useQuery hook returns. So let me illustrate that by logging this to the console. So let's log the data to the console. And if I come down here, and now you can see that we are actually getting page params and pages inside of an object. And this pages is what we're interested in. As you can see, this is an array of pages. So this is the first page, and each page will have 4 items of fruits, right? So this is what we want. So if we fetch another page in the future, then that is going to be the second item, and that is also going to have 4 items inside of the data property. So we will have to make some slight changes to how we are rendering this data. So let me remove this, and I can say data.pages, and I'm going to loop through all the pages right here. So this could be each page. And now we are going to loop through the data property inside of each page. And I can say dot map. And now we have each fruit item. And now I can return a div here. Let's also add a key saying fruit.id. And inside of here, I can mention the name of the fruit. Let's also add a little bit of class name here. So I can say fruit.item. And this is a styling that will already be present in the app.css file. So let's save this file and let us see if it is actually getting listed properly. Perfect. Right now you can see that we have the first 4 items getting displayed. So the first page is properly getting fetched. Now let's add another button right here called, let's say, load more data, which is going to fetch the second page and append the data to the first page's data. So let us go ahead and add the button right here. So we can say something like load more data, or let's say just load more, and let's define an event handler, and we need to call a method which is going to trigger the next page's data. Fortunately, the useInfiniteQuery hook provides access to a method called fetchNextPage. So we can copy this, put it inside of here, and this should do the trick. So if I come back to the network tab, if I click on load more, you can see that the second page is getting fetched. And similarly, if I click on it again, you can see that the third page is getting fetched. Click on it again and the fourth page, and click on it again and the fifth page. But if I click on it again, there isn't going to be any more API calls, because right here in this condition, we've said that if the length is going to be greater than 5, we have to return undefined, because we only have 5 pages worth of data. So we also have to disable this button when we've reached the fifth page. So fortunately, the use infinite query hook also provides another boolean right here called has next page, which is going to tell you if there is a next page or not. So we can come down here, pass in the disable property, and we can say if there is no next page, the button should be disabled. So if I refresh this page, this is the second page, the third page, the fourth page, and finally the fifth page, and now the button is disabled. So everything is working as expected. And if you're curious about when each of these methods get executed, the exact sequence of how these things get executed, let us quickly discuss about that. So the first time the component gets mounted, the data is fetched with the default initial page param to be 1. And as soon as the fetching is done, the getNextPageParam method gets executed and quickly stores the next page value internally. So you can imagine, as soon as the first page's fetching is done, the all pages is going to have 1 page fetched so far. So since 1 is less than 5, so 2 is saved internally. And when the load more button is clicked on again, this fetch next page method is called. The saved value 2 is sent to the page param. And the same cycle continues until the last page is reached. And that is how simple it is to do infinite scroll in React Query. So far, we have used the button to do infinite scroll. In the next section, we will see how we can automatically fetch data as soon as the user scrolls down to the bottom. So I'll see you there. Hello guys, in this section, let us continue the same infinite scrolling without the load more button. So essentially we'll implement what, let's say, Instagram implements, where you just scroll down and as soon as you reach the bottom of it, new posts get appended to the existing list. So let us see how to do that. I will give you a very quick overview of how we are going to achieve this. So at the very bottom of the list, we are going to have a div. Okay. We will also initialize an intersection observer and attach it to that particular div. So anytime the div comes into the viewport is the current screen, it means that the next set of data needs to be fetched. So for the intersection observer, we are not going to be implementing everything right from the very start, but instead there is a very convenient package that we can use for React called the React Intersection Observer. So as a first thing, let us remove this button. We do not really need it anymore. So come down here and we can remove this button. And the next thing is, let us install the React Intersection Observer package. So I can copy this to the clipboard, paste it and press enter. Okay, looks like it is done as well. And let's go ahead and import it. So if I come down to the documentation, you can see that we have to use this particular hook that this package provides. So I can just copy this, paste it over here, and all that I have to do is invoke it down here. And this hook is going to return some sort of an object. And if I come down to the documentation, you can see that we have the ref and the in-view that we can destructure. I'm going to put this in here. So step 2 is done. So as we discussed earlier, I'm going to come to the very bottom of the list, put an empty div right here, and I'm going to attach the ref that this particular hook provides. So what this does is, anytime this particular div comes inside of the viewport, right? It could be anywhere. The minute it comes inside of the viewport, this particular boolean right here is going to turn to true, because that particular ref is going to be in view. The minute it goes out of the viewport, it is going to go back to false. So whenever this is true, it means that we have to fetch the next call. So let us capture this value to be true inside of a use effect. So I'm going to create a use effect, and I'm going to say that anytime in view is going to be true, we then have to fetch the next page. Okay, and also let us pass in, this could be the first dependency and the in view is the second dependency. Perfect. And also there is one more thing that I want to address. I'm just going to comment this out for now. So right now you can see that we've set the limit to only 4 items per page. So to properly do infinite scrolling, I'm just going to increase the limit to something that fills up the entire page so that we can see the full extent of infinite scrolling. So I'm going to come up here, increase the limit to, let's say, 10. And as for the data, you can see that I've increased the number of fruits I've increased it to 60 right now. Now let's go back to the browser. And now you can see that the limit has been expanded to 10 items per page. Now, let us go ahead and uncomment this method. Let's save the file. Now let's go back to the browser, do an empty cache and hard reload. And now you can already see that the page 1 and 2 is already fetched, because even initially the div that we had right here, it was visible. So that is why page 2 has already been fetched. So if I scroll down, you can see that it automatically fetches page 3 and gets appended automatically. And if I scroll down even further, page 4, page 5, etc. And that is it. And that is how simple it is to do infinite scrolling like a social media application. But there is one more improvement that we can do to further improve the user experience. So anytime we scroll down, anytime there is a fetching happening, we can actually show some text here saying that there is something loading. So let us go ahead and add that. So to do that, use infinite query hook conveniently provides a boolean for that as well. So the name of the boolean is fetching next page. So let's copy it, come down here, and we can say something like, if this boolean is true, then we can show a text like loading. Okay, let us hit save, come back to the browser, empty cache and hard reload. And right now you can see that the first 2 pages have already been fetched. Let me clear this out. And if I quickly come down here, we still do not see the loading message because it is that fast. So I'm just going to come here and throttle it a little bit. So I'm going to say fast 3G, and let me refresh the page again. Okay, so let me clear this out. And if I come down here, you can see that we have the loading text just for a brief second. Okay, so this improves the user experience. That is how easy it is to do infinite scrolling using React Query in less than 20 minutes. In the next section, we are going to be looking at a feature that is probably the most important feature in the entirety of React Query, and that is called mutations. So I will see you in the next section. So far, we have only been seeing the data fetching aspect of React Query, like using the useQuery hook and using the useInfiniteQuery hook. In this section, we will look at the most important posting data aspect of React Query. How can you actually post data to the server? How can you delete data? How can you update data? So for example, if you have a to-do application, posting a to-do is a very common thing, or submitting a form could be a very common thing. We will see how React Query handles those with so much efficiency, but at the same time, it goes the extra mile to make things easy for us. So in this section, we will start off with seeing how to do a post request using React Query. And in the next few sections, we will see more features that React Query offers that make our life so much easier. Similar to previous few sections, I've already created a little bit of code to save us some time. So I will tell you what we've done. Let's come back to the website. And all that I've added is just a form to enter the post title and the post body, and a button which is going to post this data to the database. So as you can see, each post item has a title and a body. So accomplishing this is very simple if you know React. So all that I have done is added 2 state variables right here for the title as well as the body. And coming down here, I have added a form with 2 input elements, one for the title and one for the body. And we have 2 onChange handlers right here, which is going to update the set title and the set body respectively. We have also two-way binded it. And finally, whenever this button is going to be clicked on, this handle submit handler is going to be clicked on. And right now, all that we're doing is printing out the title and the body to the console. And we're also clearing out the fields. That is it. So let us see this in action. Let me go to the console tab, and we can say something like dummy post title. and then dummy post body, right? So if I post it, and you can see that we have both the title as well as the body. So the next step is we have to call a function which is going to take this particular object and then post it inside of the database.json file, right? So we have the database.json file right here. Whenever we invoke a certain function, that needs to post this particular data to the posts array. So this is what we have to accomplish next. So the good news is React Server supports post requests completely out of the box. So I will tell you how that looks like. Let us write a simple post function. And before that, you can see that we are using an arrow function right here inline in this particular useQuery fetch function. Let us also try moving this outside just because it is good practice. So coming up here, we can say something like fetch posts, and we can just copy this particular line, put it over here, and instead of this, we can just put this right here. Okay, so it is all the same. Now let us get on with what we were doing earlier. Now let us write a post function. So this was the get method right here. Now let us write the post method. So this function is going to add a post, and this takes in a post object that we see right here. And then for the body, we basically use the same thing, but except we use the keyword post right here. And then we have to pass in the post object as the payload, as the second argument. That is it. And right now, this just exists as a standalone method. Let us see how we can incorporate this method inside the React query context. So earlier, to fetch data, we use the useQuery hook, and then we pass the fetch posts method inside of the query function. But right now, since we're interested in mutating the server data, mutations are what we use. React query provides something called a mutation, and that is what we have to use to create data, delete data, or update data. So for this very purpose, React query provides a use mutation hook right here. And let us now use this hook down here. Let's come below the useQuery hook, invoke it, and similar to what the useQuery takes in, the use mutation hook also takes in an object. And we need not have to pass in the query key right here. Instead, we have to pass in a mutation function. So we can specify the mutation function, and this add post is going to be the mutation function. We know that this is the query function, and this is going to be the mutation function because it mutates data in the database. So let me come down here and put the add post here. And similar to what useQuery returns, the use mutation hook also returns an object. But the most important property that you need to destructure from this is the mutate method. And this mutate method is what we have to call wherever we have to post the data. So in this case, we are posting the data on click of the button. So let us come down here, use this mutate method, and this is where we have to pass in the title and the body. So let me actually move this into a separate variable right here, and let's put the post inside of here. And that is it. Whenever the form is getting submitted and this method is going to be triggered, this mutate function is called and the post is passed in. So it goes to the mutate function right here, and we receive the post, which is then going to be put in the database. One more thing that you have to note, let's say you have multiple mutations. Let's say you have another mutation to update a post, right? So in that case, you might have to add some alias right here. So for example, in this case, you might say something like add post mutation. And for this, you can say something like update post mutation. And in this case, use this particular add post mutation so that there is some differentiation. But since we only have one mutation going on, we do not need this. All right, let us save this file and give this a whirl. And before that, let's empty the cache. All right. So let's go ahead and say something very simple, dummy title and dummy body. And as soon as I click on this button, you can see that there is a post request happening right here. And if I go down here and I fetch all of the posts, you can see that this is getting appended to the list. And to the newly appended item, we can click on it and go to the post details page as well. If I go back to the db.json file, you can see that we have the newly created item added to the list as well. Okay, so to give you a quick summary of what we've done so far, just remember that anytime that you're mutating data in the database, you will first have to think about the use mutation hook. This takes in an object as well, and this always, as a mandatory thing, takes in the mutation function. Similar to the useQuery's query function, this also would have to return a promise. So if I come in here, you can see that this also returns a promise, and this method is what makes the API call. And this hook also gives us access to the mutate method, which we're invoking, and we're passing in the payload inside of the mutate method. And this performs the mutation. As a quick side note, this use mutation hook also provides these other details that useQuery provides. So for example, this also provides the is loading boolean, is error boolean, the error message, and we can always incorporate these into our application as well. But since you can see that the names are clashing, you can always use an alias like is mutate loading, is error loading, etc. Okay, so let's remove this now. So in the next section, we will see how we can make this entire posting process seamless. So in this instance, we posted the data, the database got updated, but at the same time, we had to manually click on this button to fetch all of the data again so that we can display the updated item. So in the next section, we will see how to instruct React Query to automatically do it right after the post operation. So I'll see you there. In the previous section, we saw that we had to manually do a refetch by clicking on this button so that we could see the newly added post. So for example, if I post something like post title and post body, hit post, you can see that a post request is actually triggered and the database is updated. But to actually see the updated item right here, we had to do a manual refetch. And this triggers a GET request, which fetches the entire list, and then that list updates the existing cache. But what if I don't want to manually fetch the data? We want React Query to do it automatically as soon as the posting operation is done. So let us see how to do that. Coming back to VS Code, I'm going to go up here and I'm going to import a hook called useQuery client. So the useQuery client hook gives access to the query client that we had provided at the very start inside of the index.js file. So if you remember, this is the query client that we provided to the entire application. So this useQuery client gives us access to that. So let me invoke this first, and then I'll walk you through the process. So I'm going to come down here, and I'm going to invoke it right here. And this will give us access to the query client. All right, so what is the next step? I'll give you a very high overview of what we are trying to achieve. So as soon as the API call, the post API call is done, we want to tell React Query to completely invalidate everything that exists in the cache. So by doing that, React Query is going to instantaneously fetch the updated list from the database. So we can make use of the onSuccess method that React Query provides inside of the useMutation hook. So inside of here, we can make use of the query client to invalidate everything that is existing in the cache right now. So I can say query client dot invalidate queries, and the first parameter that it takes is the query key of the query that we want to invalidate. We know that this is going to be the query key that we want to invalidate, and that is it. So if I save this file, come back to the browser again, and if I say something like post title, let's say A, post body A, let me clear this out as well. And you can see that as soon as I post this, a post request is made first, right? So we have the post request right here. And as soon as that is done, there is also a GET request, which is fetching all of the posts with the updated data. And we see that instantaneously the item is being reflected at the very bottom. And this is how we can do query invalidation using React Query. But there is a way to optimize it even further. We will see how to do that in the next section. In the previous section, we learned about query invalidation, which is useful when you have to change the remote data that affects the UI. It could be creating something, updating something, deleting something. So for example, posting a post in this case, and refetching the entire list of posts to ensure that the UI is in sync with the database data. So if we add a new post, let's say dummy title, and let's say a dummy body, hit post, in the network tab, you can see that we have a post request followed by a get request. Although this works perfectly fine, there is still room for a lot of improvement. If I click on the post request, you can see in the response that we have the new post object that was just created being returned to us, right? So the industry standard is that the API calls return this. It is pretty common for the new object to be automatically returned in the response of any post API calls with the new ID as well. So if we're getting the new object in the response, then we have to ask the question, why do we have to fetch an entire list just to show one new item that we already have received in the post request, right? The good news is React Query, it lets us take this response object, add it to the internal post cache list, and show it instantaneously in the browser. So we do not have to make an additional API call. Let us see how to do that. Coming back to VS Code, step 1, we can comment out the extra line for the invalidation right here, because we don't want the additional fetch request being made anymore. And step 2, we get the response of the post API call as a parameter right here. So onSuccess receives data, which is the newly created item, as a parameter. Now step 3, we now have to add this new data to the internal posts list cache. So we can make use of the query client dot set query data method. This function is used to update the query cache. The first argument is the query key. We want to update the posts query, so let us put that in here. The second argument is a function. This function receives the old query data as an argument. If you think about it, the old query data is what is present in the query cache right now. If we come to the browser and open up DevTools and we scroll down, you can see that it is an object with several properties like status, headers, config, as well as the data property. Inside of the function, we need to return the new value of this entire query cache object with the data property alone updated. So whatever we return from this function will rewrite the cache that is existing. So let us now return the cache object that needs to replace the current cache. So as a first thing, I'm going to spread out the existing cache object, which we get right here, because we still need the additional other properties. The only property that we need to update inside of here is the data property. So let us do that next. Let us spread out everything that we already have. So we can do something like old query data dot data. And next up, we need to take this new data, this new item that's been added, and then let's go inside of the data property so that we can get the object. And that is it. So if I save this file, come back to the browser, let's clear this out and let's post a new item. I don't really have a title in mind, so I'm going to say something like creative title. And then here, creative body. And if I hit post, you can see that there is no get request being made, only one post request. But for some reason, it is not getting reflected right here. Let's go back to the code and let's see what's the problem. All right, so the reason is the way we've mentioned the query key right here. So we have to match what we've used previously during the useQuery fetch. So right here, we've put it as an array, right? So even though there is just one term, we have put it as an array, and that is exactly what we have to copy right here as well. Okay, so let us enclose this inside of an array. So let us save this file, come back to the browser again. So let us actually go ahead and create another post. So we can say something like super title, super body. All right, so let me hit post now. And right now you can see that it instantaneously adds this item to the list. And at the same time, there is just one post call being made right here, which is this one. And the second one is just a pre-flight call. Let me remove all of this. So this is how we generally handle all of the mutation response. This is a little bit more code than just invalidating the query like what we did in the last section, but it saves us the additional GET request. We can also make this one step even better by making use of optimistic updates. So let us look at that in the next section. In this section, we will be looking at how to do optimistic updates using React Query. So let us look at what optimistic updates are. As the name indicates, it implies updating the state before performing a mutation under the assumption that nothing can go wrong. It is typically done to give an impression that your app is blazing fast. With that said, you do have to cater to scenarios where the mutation can in fact error out. Managing these optimistic updates is typically not so straightforward, but React Query, on the other hand, does simplify it to a very good extent. So now that we know on a very high level what optimistic updates are, so let us look at how we can apply optimistic updates on our posts.rq component. So to do this, as a first step, we need to comment out everything that we've written on the onSuccess callback. We will not be needing this. We require 3 different callbacks. So the first one is on mutate, and the second one is on error, and the third one is on settled. Now let us look at the first callback, which is the onMutate callback. This onMutate callback is called before the mutation function is even fired. And this receives the same variables or the payload that the mutation function receives. Okay, so we know that the mutation function is this add post, and this receives the post payload. And this is exactly what this function receives here as well. So let us put something like new post right here. Now, the first thing that we want to do inside of this function is to cancel any outgoing refetches so they do not override our optimistic update. So we can do it by using the query client instance and accessing the cancel queries method inside of it. And we also have to pass in the query key of the query. And in this case, it is going to be posts. Also make sure to use this as an array because that is what we've done here as well. And this operation is typically an asynchronous operation. So you will have to put an await keyword in the front and you will have to put the async keyword here. So when I was going through the docs of useMutate for optimistic updates, this particular operation was a little confusing to me. So let us see in depth why this command is very important. When you perform an optimistic update, you want to prevent any in-flight queries from invalidating your optimistic update. Here's why. First off, we have to prevent race conditions. If there is an ongoing fetch for the posts query and you try to add a new post using the mutate function, there is a chance that the ongoing fetch might complete after your optimistic update, therefore overriding the optimistic data with the stale data from the server. And the second reason is to ensure consistent state. By cancelling the ongoing queries, you ensure that no stale or incomplete data is accidentally applied to the UI after the optimistic update. So this will keep the UI in a consistent state. Alright, let's move on. Next, we need to get a hold of the current query data before we make any updates. This will help us roll back in case the mutation fails. And to get a hold of the current query data, we use the getQueryData method from the query client instance. So we can say const previous post data query client, and we are accessing the getQueryData method, and we also have to pass in the post query key. And finally, as a third operation, we have to update the internal posts cache with this new item that we are receiving right here. So to do that, we can just copy this existing lines that we've written right here. This is what we need. The only difference is that we do not get the new data in this particular format, but instead we get the exact payload that we passed into the mutation function. So what we can do is, we can remove this, open up an object, and then we can spread out the new post right here. In addition to this, we also have to do one more thing. If we go to db.json right here, you can see that each item, along with the title and the body, we also have a unique ID, which we do not have in this new post, right? So let us add an ID here as well. So we can say old query data dot length plus 1. And let us also make this ID into a string, because in db.json, every ID is a string right here. So because of this line of code, we have now updated the list of posts even before making the post API request. And finally, from this onMutate function, we are going to return an object with a key value set to previous post data in case the mutation errors out. So let us come down here, open up an object, and we have to pass in the previous post data. And that is it for the onMutate function. Let us move on to the onError callback. So this onError callback is going to get 3 different arguments. So the first one is going to be the error object. But we will not be needing this in this function right now. So let us put an underscore before it. And the second argument is going to be the payload that was passed in here to the mutate function right here. So this is just going to be a post object, which we will also not be using in this callback right now. So I have put an underscore at the beginning. And the third one is going to be the context object. So this context object is going to give us access to the previous post data that we returned from the onMutate callback. So on the event of some error happening, we can reset the cache list with the previous cache data using the setQueryData method like we did before. So let us use the query client instance dot setQueryData, and then the first argument, as we did previously, is going to be the posts array, and the second argument is the context dot previous post data. So the rolling back logic on the event of some error is as simple as that. Let us move on to the last method, which is the onSettled method. This callback is triggered when the mutation is successful or when there is an error. Inside of this method, all that we have to do is fetch all of the posts so that the server data is in sync with the client data. So we can say query client dot invalidate queries, and then as we did previously, we pass in the posts item right here, and that is it. If your application is such that there isn't going to be a lot of concurrent data updates happening in the server, then you don't have to put anything inside of here. But this is just an added precaution, and the user is not going to notice any difference. And we have done everything necessary for optimistic updates. Let's go back to the browser. Let's clear this out. And also let us make sure that it is throttled. All right. So for the post title, we can say something like React Query. And for the post body, we can say something like React Query is amazing. So let's post it. And now you can see that this showed up even before the post API was completed, right? So we're optimistically updating it with the assumption that nothing will go wrong. And then a refetch is done in the background and the list is synced with the server state. As a practice, try simulating the error condition by changing up the API URL endpoint and show an error message on the screen with the help of the isError boolean that we get from the useMutate hook as we discussed a few sections ago. We have now come to the end of this course of working with React Query. I hope that you're now in a very good position to handle both queries as well as mutations. If you found this content helpful, please do leave a like and subscribe to the channel if you haven't already. I will see you in the next video.